Hello, civil engineers. Welcome back to the lecture. So here I'll teach you how to prepare the Excel sheet. I mean, of course, now you are reached to such a position where you can prepare this particular Excel sheet on your own. But right now I'll teach you how it has to be calculated, and maybe in one lecture I'll teach you how this shape of the bar has to be done. But I feel to the level of teaching I've done so far, you can prepare a shape something like this. Quickly, I'll give you an example here. Okay, I think you know that, but still I'll quickly do that, and later I'll give you one more class where I'll teach you. Okay, what you need to do, you come to the shape option. Okay, select the shape like this, and then then you drag it like this. This is one shape. Okay, then this is another shape. Okay, you select it once again. Select it once again. Okay, and then exactly, then you take it one more, and then you join it. Okay, so this is how the shape will come. And next, you have to select all the three, right click, go to the group, make a group. Okay, and then you select on that. If you want to increase the font, come to the shape. Okay, then shape outline, come to the weight, and you can increase the weight of that. Make sure everything is correct. Just in a hurry I'm doing that, but I hope you can do all these things. Since we already done for the column, you have done for the footing and all, I think you should be in a position to do for this. Okay, good. So I'll teach you how it has to be done, all this calculation now. Yeah, so first we'll start with this particular drawing. Okay, I'll start for this particular beam. So how do you write this beam? First you have to write this beam. You need to number it. Okay, all the three beam, all these two beams I'll take simultaneously. I'll take this beam simultaneously. So what I'm trying to tell, I need to write it is falling on the grid number A, B and C, and on 1. So I'll write here plinth beam. It's a plinth beam layout. So plinth beam A, B and C, or I can say A1, B1 and C1 grid. Okay, the same thing I've written it here. What I've written is plinth beam along grid A1 to C1. This is A1 to C1. Okay, you can write in your own way also. You can write plinth beam along A, B, C, grid number 1. That also you can write. Okay, fine. So first, always remember, we'll start with the bottom reinforcement. You can even go with the top reinforcement, but we'll start with the bottom first. Okay, so come here. So in the bottom, what reinforcement I have? So this is my bottom reinforcement. Okay, so you can know, see all these things you already understood. So I'll just give you an idea. That's it. Okay. So this is my bottom reinforcement where it is written. You're supposed to provide a 20 diameter 2 bar, and also you're supposed to provide a 16 diameter 2 bar. You know that. So 20 will be outer and inside will be 16 diameter. Since the diameter are different, I'll make this 2 times. That means in the Excel sheet, I'll make one for 20 diameter. I'll make one for 16 diameter. Since diameter is different, so your cutting length, your this thing, what is that? Weight of the steel will be different. So I cannot say 20 and 16, I cannot put together. So that is why I've written bottom main bar 20 diameter. Okay, good. How many numbers are there? 20 diameter, how many is there? It is written 2 numbers are there. Fine. So I've written 2 here. I've written number of bar 2. There is no spacing here. This much is clear. Number of member. How many members are there? Right now I'm doing only for one column. So there is only one member. Okay. So I've written 1 here. Got it? This much is clear. Now come to this portion. So what is this portion all about? See, this portion indicates, the black one indicates my column inner to inner. So this black one, if you want, I'll show it here. Okay. Yeah. Let me cut this part, and I'll put it here. Okay. Yeah, I'll paste it here. Good. Huh. So this black color you can see here. This black color, whatever I've written, no, this black color indicates my length on the real beam from this column inner to this column inner. This is what I am indicating. This black indicates this. Okay, great. Fine. I mean the bottom, you can come to the bottom. I'll take it to the bottom. This inner to inner I want. This length I want. This length I have calculated, that is 10,150. This portion, you can see the red portion here, and this red portion you can see. This is this particular thing. I'll do with the same red color only here. Okay. So you can see from here, it's a development length. This straight portion on the left side, this straight portion on the right side. You can see this indicates the red and red color. And then this L shape, whatever you can see, this indicates this L shape on the right side, this L shape on the right side. Got it? This much understanding you have. The same thing I represented here. Now, if I ask you one question, this entire red thing is my development length. This entire red thing is my development length, but I want to find my horizontal extra and vertical extra. So I mentioned it in this way. This much is clear. Good. Now first I'll find the horizontal length, that is a red color. How do I find? So if you look at the drawing very closely, these people have mentioned us, these people have mentioned the distance from center to center. These people have mentioned the distance from center, that is center of, these are the columns, okay? This is one column. This is my column number 1. This is my column number 2. And this is my column number 3. Great. So these people have mentioned the distance from center of the column to the center of the column. Yeah. From this center to this center, and from this center to this center. But what did I tell you? But what did I tell you? Wait. Yeah. But what did I tell? My concern is from the column inner to column inner. Can you not find this? Very simple. I'll first add this. That is from this center to this center, and this center to this center I'll add. From there, if I remove this much length, that is half face of this column, half face of this column. If I remove, will I not get the complete length of this? Obviously, I'm going to get. So I'll do the same thing here. I'll do it here. And later I'll show you how it has been done here. Okay. I'll do here. So observe here. Plus, I'll open the bracket on the Excel sheet. What is this center to center? From this center to this center, it is 5525. I'll write 5525 plus. Again, I'll add this center to this center. How much it is? 5125. 5125. So I got from center to center. I'm telling from inner to inner I require. That is called as clear span. So if you agree with me, this size of the column, this column size is 500. Now, where did I get this 500? It is given in the drawing, but I'll write here. The size of the column is 500. This size of the column is also 500. That is both breadth and depth of the column is 500. And this column is also 500. Okay, great. But my concern is from where? My concern is only from the center to center. I want this distance now. Yeah, I want this distance. So if I remove half of this column from here, if I remove half of the column from here, and if I remove half of the column from here, okay, if I deduct this from the length what I got, will I not get the clear span distance? Obviously, I'm going to get. I'll get from this inner of the column to this inner of the column. Right now, I was getting from center to center, but if I remove half of this column, because this entire column is 500, but only this length has gone here. So this will be 250, half of that. So from here, if I remove half column, and from here, if I remove half column, I'll get definitely this clear to clear span. So we'll do the same thing. I'll write minus here, minus how much? 250. Why 250? Because 500 is the overall. From center, I want to remove. Only from here, 500. So it will be 250 from the left side and this 250 from the right side. Agree with me? Close the bracket. 250. Close the bracket. Finish. This is your clear span. How much did I get? 10,150. How much did I write here? 10,150. Same thing I've written. Understood? Very simple. Okay? Fine. This is done. So once you finish this, next what I'm supposed to find? Next, I'm supposed to find this red color. This red color you can see horizontal length. This red color horizontal length I'm supposed to find. But I know that this complete red color is actually my development length. So from where did you get that? I'll show you from where did I get that. So if you look into this drawing, these people will give you all these things. Okay. So you see here, this is my typical beam column junction. What is this? This is my typical. Yeah. This is my typical beam column junction. So here they are indicating that this is your column, okay? These people are indicating that if this is your column, whatever reinforcement you put in the beam column junction, this part will be your development length, where from the outer face of the column, the outer face of the column is from here. I mean, yeah, from the inner face of the column, not outer, inner face of the column to this complete L, whatever you have. This, whatever you have, no? This part. Wait. This part, whatever you have. This is your development length. How much it is? So they have shown here 57 times the diameter of the bar. Same thing even on this side. Okay. Same thing even from here also. Where? From bottom also. I did for the top. Similarly, your bottom bar will come, no? Similarly, from here to the top. How much it is? It is 50 times the diameter of the bar, 57 times the diameter of the bar. This is clearly mentioned here. So we'll take the development length as 57 times the diameter of the bar. This much is clear? Good. So I'll go back to that. So what I'll do now, I know 57 times the diameter of the bar, but you remember one thing, whenever we put the beam reinforcement, this beam reinforcement, whenever we provide, no, we don't take this bar completely from this outer of the column to this outer of the column. We never take. Why? If you take it, what will happen? Your bar will be exposed to the atmosphere. Because of that, again, the corrosion is going to happen. So always we'll leave a cover, right? So since this bar is going in this column, since this bar is going in this column, and since this bar is going into in this column, that means the column cover we need to deduct from both the side. Okay, very simple. We need to detect the column cover from both the side. So what is the cover for the column? It is 40 mm. Right now I'm doing only on the left side. So right now you see here, this side I'm doing. You're getting my point, no? So this side, what I have done, this is what is the column width. The column width is 500. From 500, if I remove one cover, I'll get my this length. Say I want to find this length. Okay, in case for someone who is getting confused, I want to find this horizontal length from here to here, but I won't take the complete length. If I take complete length, I'll not get the cover. So I'll stop up to here. Then what will be my horizontal length? My horizontal length will be whatever is my column dimension. From there, you deduct one cover for the column. So I've done the same thing. Okay, I've done the same thing. I've written 500. That is the size of my column. This is the size of my column. And from this column, I've taken out, I've deducted the column 40 mm cover. This 40 mm cover, if I deduct, I'll get the horizontal length. So I've done 500 minus 40. Got it? So that is why I'm getting 460. On the left side, I did same thing I should do on the right side also. I can come to the right side. So again, this is your column. This is your column. And again, this red color bar which has gone. This red color bar which has gone, it is not going completely outside. It will stop up to here. Fine. If it is stopping up to here, that means we have to leave a cover. So practically you'll be leaving a cover on the side. Okay. So this will be a 40 mm cover you are going to leave. Good. Then what will be this red color distance? What is the size of your column? It is 500. So 500 minus cover is 40. So here also it will be 460. I won't write for here. See 500 minus 500 minus 40. Understood? So you got this clear span length first. From here to here you got the length. That was 10,150. Then you got this red color distance and you got the red color distance. That is 460 on the left side, 460 on the right side. You may have a confusion in your mind. Sir, from where you're taking that column as 500 mm, then you come to this drawing. I've given you this drawing. So here you can see this is a column size they have given. Okay. C1, C2, C3, C4 column. All column are 500 by 500, 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 and only C6 column is 550 by 550. It's okay. Anyhow, C6 column we are not encountering now. C6 column is coming here. When you're doing somewhere here, you will see C6 column is coming here. Right now we are doing here. So here all the columns are 500 by 500. If you're still worried, if you still want to know, if you want to get the proof for that, again, you come and check here the column layout. Yeah, see here. Where is your C6 column? C6 column is coming somewhere here. C6 is here. So right now C1, C2 and C1 column is 500 by 500, 500 by 500, 500 by 500. Clear? Good. So we'll go back to the Excel now. This much is clear, no? This is also understood. Now it's very simple. Now we got the horizontal length. Now we got the horizontal length, and we know that this complete development length, like this, it is 57 times the diameter of the bar, right? So this complete is 57 times the diameter of the bar. Fine. And in that this horizontal length I have got 460. So in the complete development length, in this complete development length of 57 times the diameter of the bar, if I deduct only the horizontal part of 460, will I not get this vertical height? Agree with me? This is overall development length. This overall development length, we saw it is 57 times the diameter of the bar. In that, we know the horizontal is 460. So if I want to find this vertical overall development length minus if I do the 460, will I not get this vertical height? Obviously, I'm going to get, we'll do the same thing. So I brought my cursor here. I've kept it here. What I've done, 457 into D. So D is the diameter of the bar. Right now, I'm looking for a 20 diameter bar. So I'll multiply this by 20. If you don't believe there, I'll just do it here. Okay. So plus 57 into, I'll not write 20. Directly come here and click on this 20 diameter. So 57 into D, okay, minus say 460, minus 460. Enter. How much you're getting? 680. I got 680. Very simple. Got it, no? Fine. So if you get 680 here, obviously here also it is 680. You just interlink, or you can again come and type here 57 into diameter of the bar minus this 460. That's it. So once you do this, finish. Your BBS is ready. Understood up to here? Great. So I'll delete this part now. Now it's simple. Bottom main diameter is 20 diameter. Number of bar was 1. Dia of the bar was 20 and number of bar was 2. How you'll find the cutting length? Very simple. Add this 680 plus 460 plus 1000, 10,150 plus 460 plus 600. If you add everything, we'll get the total cutting length of the bar. I'll do it here now. So total cutting length will be 680 L, this one, okay? 680 plus 460 plus 460 plus the clear span 10,150. Okay, wait. Yeah, this plus this 460 on the right side, this one plus this vertical of 680. Okay, how much will happen? 1 2 3 4 5, 1 2 3 4 5, and press enter button. Finish. So 12,430 is the total cutting length that is required. Finish. You'll ask me one question. So what about the bend deduction? Bend deduction is not required. Okay, since we are directly taking it in this way, okay, and since we are taking that 57 times the diameter of the bar, see why bend deduction is not required? For a very same reason. These people have directly given that, see, this is 57 times the diameter of the bar. This is called as your development length. Here already the bend deduction has been applied. Okay, so you don't have to do the bend deduction. But again, I always repeat, but again, if your company is following that, no, after doing that also we are supposed to apply the bend deduction, you're free to do that. Come here, minus, open the bracket. How many bend deduction you'll do? 190 degree I'm getting here, another 90 degree I'm getting 290 degree. So for 190 degree, if it is 2D, for 2 it will be 2 into 2 4D. So multiply minus 4 into diameter of the bar is 20 and close the bracket. This will be a cutting length according to your company what you're following. But usually when we take the development length directly, which is given in the formula 57 times the diameter of the bar, you don't have to apply bend deduction. But again, if a company does that, or if your senior says that, or if you feel that method is correct, you can do that. You're free to do that. But I won't be doing, so I'll delete that. Anyhow, I'll keep both the answers here. Okay, fine. But I'll be doing only without the bend deduction. Great, fine. Now, one question. This 12,430, whatever length you have got, what is that? It's a total cutting length. Imagine what is the length of your one rebar? It is 12 meter. But this length has gone beyond 12 meter. So our one straight bar which is available in the market is 12 meter. But here the length what we are getting is 12,430, which has gone beyond 12 meter. That means we need to provide lap. We need to provide lap now. So what we'll do? How do you provide lap? You know that how to provide the lap? So again, what will be the lap length? Again, if you go back to the drawing, here they have given, okay, here they have mentioned that your lap length should be minimum of development length. So in the drawing, it is written, oh, so it was written here in the drawing. Let me search for that. Anyhow, okay. So it was written here. I'm not able to find now. No problem. I'll show you later also. Not an issue. Just understand now. Okay. I'm not able to find that. Anyhow, let me check here. Yeah. See here. What is mentioned? Splicing length. See, lap length, whatever I'm telling, lap length is also called as splicing length according to the Indian Standard Code Book. If you refer Indian Standard Code Book, it is written splicing over there. Okay. So it's written splicing length shall not be less than development length. Means whatever splicing you're doing, whatever lap length you're doing, whatever is your development length, minimum that much we need to provide. It should not be less than that. So here what we'll consider our lap length to be equal to be development length, which is 57 times the diameter of the bar. So I'll go back to the Excel sheet. I'll say what I'll do. I'll see whatever length I've got. I'll close the bracket. I'll close the bracket here. So this is the answer what we got. But since we find that this answer, whatever we got, is short, I mean, we need to add one lap length. So I'll write plus 57 into diameter of the bar, 20 diameter. So now this becomes my total cutting length. So I mean, this becomes my total cutting length. Okay. This becomes my total cutting length, including the lap length. So my lap length is 57 times the diameter of the bar. Got it? Very simple. Now what will be your total? Okay. What happened to this? It's correct, no? And why did we get? Okay, fine, fine. No problem. Correct. Yeah, got it, right? So this is 13,570 is a total cutting length. So we found the total cutting length of one bar. Now this is in mm. I'll convert this into meter. So what I'll do, I'll select this one and I'll divide it by 1,000. So 13.57 meter is a total cutting length. Okay, I mean cutting length of one bar. How I'm going to find the total cutting length? So total cutting length will be cutting length of one bar multiplied by number of bar into number of member. So 13.57 multiplied by 2 multiplied by 1 will give me 27.14. So this is a total cutting length of 2 bar of 20 diameter. Now I need to find the weight of the bar, right? Since I'm using a 20 diameter bar, I need to go to the 20 diameter column. And what I'll do, I'll click on 27.14, which is a total cutting length. I'll multiply this by the unit weight of 20 diameter, which comes out to be 2.47. You multiply 27.14 into 2.47, you'll get 67.036. So this is a total cutting length, I mean total weight that is required in your bottom main bar of 20 diameter if you're using a two numbers. Okay, clear? This much you have understood? Great. Now you may think, how do you do this practically on this side? So let us say if this is my beam, I'll do it here. Just to give you an idea. Okay, if this is my beam, consider, let us say if this is my beam. Okay, this is my beam. I'll draw column here. This is one column. Okay, my second column will come here according to our drawing, and this is my third column. Okay, and what is the so what is the total cutting length we got? It is 13.570. So 13.570 is my total cutting length what I require. So my one bar will start from here. I'll go with the bottom bar only. Okay. So bottom, you'll start here. Your development length will start here. I'll take a bigger one. Yeah. You'll start your development length from here. Okay. This green color. Okay. I'll take the red only just to visualize the same thing. Okay. Your development length will start from here. Up to here is your development length. After that, it is your straight portion of the bar, which was black in color. It will come completely up to here. Okay. It will come completely up to here. Okay. And then this is a red portion, which will come like this. Okay. And then it will get something like this. But practically on the side, this is not possible because this entire cutting length, we have got 13.570, which is greater than 12 meter. So in that case, what you're supposed to do, in that case, what I'm supposed to do, I'll bring my this bar. I'll bring my this bar somewhere here. Okay, because your bottom you cannot lap at the center. Bottom you have to lap somewhere here. Okay, bottom you have to lap somewhere here, or near the support you can lap. So near the support you can lap in bottom. Yeah, you can lap it. Only in the center you should not lap. I'll bring my bar up to here. Okay, or I'll stop my bar up to here. Okay, I can bring up to here. Okay, I'll bring up to here my bar. I'll take it to the top. Okay, I think fine. I'll take it to the top only a bit here. Okay, up to here I'll bring my bar, and here I'll lap my bar. What I'll do, I'll lap my bar. So this is my lap length. This lap will happen like this. Give a lap, take it like this, and then this bar will be bent in this way. Okay, got it, no? So this extra lap, whatever you can see, no, this is your lap length, which is 57 times the diameter of the bar which you have taken. So practically you can do in this way. Else, if since we are using a 20 diameter bar only, this is one way of lapping. If you cannot lap here, you cannot lap in the center. Again, you have to lap near the support only. Else you can do another way of lapping. I'll go with only one same color. Okay, Again, you'll bring your bar like this. You'll bring the bar up to here. You'll bring the bar up to here. And next bar you can lap here. So you lap the bar here and lap it like this. I mean, I'll make it nice. So this portion you are going to lap like this. Take it straight and then do it like this. You're getting my point? See, there is a lot of difference between doing it on the paper and doing it on the site. Paper I did. I got 13.570. This much steel is required. This must finish. But execution point, you need to plan accordingly. Okay, execution will be done in this way. So what you'll do, you'll bring one bar which will go straight up to here. Let us say this is 12 meter. Okay, this 12-meter bar you'll cut like this and bring. So this will be your 680 and this is 460 and this is 10,180. So by the time here it reaches, it's a one complete bar has got ended. Now you'll bring one more bar where you'll give a small bend to that, that is lap. So this lap length will be your 57 times the diameter of the bar. It will be bent in this way, okay? It won't be get a cross like this. A slight bend, something like this, it will happen. Go and then this L will happen, okay? You getting my point? This is what we do practically on the site. Or you can even follow the second method. See, again, it depends. Like whatever I'm doing, it's correct. But on site, what will happen since we'll be doing a lot of bar will be used on the site. If there is any waste bar which has fallen, you can take the same bar and you can do the lapping. But when we make a payment will be done for this only. This is the total cutting length what we got it. That is how you're supposed to do. I hope you have got an idea. In spite of this, if you still have a doubt uh, for the concept what I've explained, you can always get back to me. Okay, great. So up to here you practice it. After that, I'll explain in the next lecture about the bottom main die 16 die. Only one bar 20 I did, 16 is also left. Top bar is left, top left is left, top right is left, and top middle is left. After the stirrup is left. So all those things I'm going to teach you in the upcoming lectures. So up to here, practice it. Try to prepare the Excel sheet, and in future lectures I'll explain you that. We'll see you back in the next lecture.